Hello, today we are going to see the production calculations on draw frame. So let us see the draw frame gearing which is shown here. This is slightly a modern draw frame gearing that is shown, and let us just go through the wheels that are there which are driving the various parts of the draw frame. So let us first see how the front roller is driven. This is the motor. There is a motor RPM that's given, and via these pulleys through these wheels 33, 131, 84 and this 33, this is the front roller which is driven. So these are the only wheels that are involved. This is the route. When you come to the next, back roller is driven through the wheels. This is the back roller which is driven through the wheels 33, 131. Then you go to this shaft you can see here which goes through, which is 42. Then there is a carrier wheel here which is 109, and then this is the draft change pinion or the CP. Right now it is 66. Then you see the middle roller, that is this roller which is driven by the back roller through the wheels. Once the back roller is driven, the back roller drives the middle roller through V, G, which is known as the brake draft change pinion, and from V, G, 143, this is 143 and 18. So this is the route to drive the second roller. So now there are two things I would like to point out over here. One is the draft change pinion. This, if changed, only affects the speed of the back roller, which will in turn affect the surface speed of the back roller, which helps us to change any draft values on this machine by just simply changing this particular wheel. Since it does not affect any other speeds, only the back roller speed, and in turn, accordingly in the same proportion, it will of course affect the second roller speed also, but it will be in the same proportion. So it does not affect the brake draft that would be applied between back and the middle, but it only affects the speed of the back roller. It will change the speed of the back roller, and because the ratio between back roller speed and the front roller surface speed will change, you are able to change the total draft. So that is why it is known as a change pinion. Then we come to this wheel, that is G, which is shown here, and it is known as a brake draft wheel because from the back roller whatever speed is coming, it is coming to the middle roller, and by changing this G, again we are not changing any other speed except the second roller. So only the ratio between the back and the second roller will change, and it will not affect any other speeds in the machine. So if you want to change the brake draft, this is the wheel that we need to change. So with this background, I want you to calculate the brake draft, the main draft, the total draft, and the front roller surface speed, assuming the motor pulley as 220, which is this motor pulley as 220 over here, because there's a range which is given. Assume it to be somewhere in between 220, and by taking this as 220, you will get the answer as 258.9. Just try this. Um, and then we will see if there are some problems, we'll solve it later. This we have already done it before the draft calculations, that is why I'm not going into this again. So we go to production. So how to calculate production on a given machine? So for the current situation, it is draw frame. So production is always expressed in length or weight. So here let us see how to calculate production or convert production from length into weight. I want to know what is the production that this machine gives me per hour. So for that I will require two data. One is the length that is delivered by the machine in meters, and the second data that I require is the linear density or the thickness of the output sliver, which would be in kilotex. If I have this in these particular units, I will get directly the answer in kgs per hour. So this would be the formula for me. So how can I explain this formula? We already know that kilotex is the weight in kgs of 1000 meters of material. So if this length of material delivered per hour in meters is say whatever X amount, so if I were to place this just below over here in meters, so then that multiply by ktex divided by 1000 would be the formula just by cross multiplication. So this is the formula how we have got this. How to, so only one thing remains, kilotex would be given to you, and what about the length of sliver delivered per hour in meters, how to calculate this? This is nothing but it's simply the output of the front roller or the final roller coiler calendar roller, which would be if you get it in meters per minute, which you calculated in the earlier slide through the gearing. So that value will come here, multiply by 60 would give you this value meters per hour here, for which you can substitute here. Take the kilotex value of the sliver, divide by 1000, and you will get kgs per hour. So let us take one example here. The front roller is running at so and so 258.9 meters per minute, which we have calculated earlier, and the sliver delivered is 5 ktex, and the production in kgs per hour, kgs per hour per machine with 2 heads. Production in kgs per machine per shift of 8 hours at 100% efficiency. So these are the answers which I want you to calculate and see whether they match. What happens if the output sliver is expressed in English system instead of direct system in ktex? It is given in say Hank. So in that case, we already know that tex is equal to 590.5 divided by English count, and kilotex is tex by 1000 as per the definitions of both of them. So therefore, combining this, I can say ktex is 590.5 divided by Hank into 1000. If the linear density of the output sliver is in Hank, then the production in kgs, the earlier formula that we saw, I can substitute instead of ktex over there this entire equation. So length of the sliver delivered per hour in meters, and then there was ktex here in the earlier formula. Instead of that, I put 590.5 divided by Hank into 1000, and the earlier 1000 is already there, divided by 1000. So this would be my final formula if in case the output sliver is expressed in Hank or in English system or the indirect system as we know it. Answer you would get in kgs per hour. So if the front roller is 258.9 meters per minute and the sliver delivered is like this example where it is not given in ktex, it is given as Hank, then you need to calculate the production per hour, and this would be your answer. So now let us go to one more topic, which is efficiency. So before going into efficiency, let us know the difference between actual speed and expected speed. Now imagine that the machine is running during a shift without any stoppages, and it runs, so it will be said to be running at 100% efficiency if it runs without any stoppage at all. This would be the production that it gives would be called as a expected production. But during the shift, the machine actually stops for some time. It is idle due to various reasons for a short time or a long time. So the reasons could be can changing, it could be minor cleaning, some breakdowns. So sliver breaks on the creel. Suppose there is roller lapping, so you need to stop the machine, clear it. Trumpet could choke. There is a shortage of feed can, or even power failure at times. So due to any one of these reasons, the machine might stop for some time, and this leads to loss in production, and therefore the efficiency of the machine would decrease. It would not be 100%. So if due to stoppages the actual production the production would reduce, and the production, this particular production which you actually get, is known as actual production. So from that, these two values we can calculate efficiency percentage. So efficiency percentage is the ratio of actual production divided by expected production into 100. So in case you can just reshuffle this, and you can find out actual production in case you know the efficiency of the machine. So in the problem, if efficiency of the machine is given, whatever production we calculated earlier using the earlier formulas, if you simply multiply it by efficiency divided by 100, what you would get is the actual production in kgs per hour. So this would be your formula now. If the linear density of the output sliver, the first formula that we saw, if it is given in ktex, then in kgs per hour, the formula would be length of the sliver delivered per hour in meters into linear density of the output sliver in kilotex, multiply by efficiency divided by 1000 into 100, which would be your production calculated in kgs per hour. So thank you very much.